Number 7, right before it. Cool. Do you have a definitive question or just? Okay. Let's go through this. So my first step is our given. I'm going to shortcut that by just putting an arrow there. And we'll put given because I'm pretty sure you guys can copy stuff, I would hope. My second step, we can get points for this. We know we're going to turn a congruent symbol probably into an equal symbol. So I'm going to go ahead and say that AC is equal to DF. And I'm going to have BC is equal to DE. All right, we need to prove that AB is congruent to EF. We need AB is congruent to EF. Currently, we have AC is equal to DF, and we have BC is equal to DE. So let's put some tick marks. These are kind of hard tick marks because we know that this entire length here would be congruent to this entire length here. It's kind of like the next proof, but a little bit different. But it follows kind of the same logic. Now, if I didn't know what to do, if I'm on the test and I have no idea what to do next, so we have given, we have definition of congruence. I'm trying to relay information to people, and I'm not sure what the next step is. Here's a good bet. Do you see how we have segments that are constructed of smaller segments? I'm probably going to at least try the segment addition postulate. I'm going to see if that can help me. So our segment addition postulate will let me go, oh, AB plus BC equals AC. So let's start there. Let's define that one line as AB. Sorry, I can't see all of it. AB plus BC is going to go ahead and equal that entire line AC. I'm just going to check to see if I have space to do it in the next line or not. I'm sure I gave you enough room for that. I did. So we will have our other one is going to equal, so we'll have DE plus that EF is going to equal that entire DF. All right, yeah, sorry.
Is where a test would every single statement get its own line? Like would BC equals DE get its own line?
I'll give you space for it. You don't have to number it, though. You don't have to make this. So I'm just going to put a 3 here because they're using the same postulate, right? The segment addition postulate. Now, let's be clear. In the future, we won't have individual lines. We'll just have blank spaces here. This is just to keep stuff organized right now. So you can either write them as 2 individual lines like I did here and just have one number. You can put them all on one line, or you can actually number this as a 4 and then write a 4 here and rewrite that statement. I'm just going to keep myself organized. I'm just going to put 3 includes both of these steps, so 3 goes there. Does that answer your question? Okay, cool. All right. Now what we need to do, I guess there's a couple ways we can handle this. So we know that BC equals DE. What's the easiest way to go next? Because I'm not overly happy with how I did it. Because ultimately we can use the transitive property to hook these two things together, but it's a little difficult to see because we can make that statement true. We can make that statement true. It just is a little hard to picture. Can we put a pin in this proof? Who asked that question? Who asked that question? No one asked this question? You asked the question, didn't you? Number 7. Yeah, I'm not 100% happy how I set this up or put it. It's a more difficult proof than I wanted it to be. Because this is true, we can hook it up by the transitive property right now. So the transitive property will allow me to write this DE plus EF equals AB plus BC. We're then going to be able to cross things out. But I'm not 100% happy at you guys picturing this at this level. It's a little bit more difficult than I want it to be. So I'm just going to put a pin on it, and maybe we'll cover it again in the next unit. Okay? Don't expect anything like this, because this is a weird connection that we haven't really talked about that much. I kind of put more of an advanced one on there. So I can make this step, which allows me to rewrite it, but I'm going to stop right here. I'm not going to push through and just say, let's just put a pin in it for now. Okay? We're going to put a pin in number 7. So if you had a question on number 7, you probably should have, because we're kind of skipping kind of one small fact with it. If you got it and you understand it, awesome job. But I'm telling you, there's actually an advanced step that happened right there that I don't want to go into because it confuses people a little bit. All right, besides 7, what other questions do we have? Yeah, Sanjay.
For number 1.
Yeah.
Statement like 2.
Statement 2, so we have angle 1 and angle 2 form a linear pair. That's given. Now remember, whenever it says a fancy word, we usually go to the definition, usually. But we learned on this lesson that linear pair, the definition of linear pair only says that they're a straight line. If you don't believe me, look at the definition of linear pair. It just says they make a straight line. But somehow they said they're supplementary. So remember, linear pair occurs 3 times. It occurs as a definition, a postulate, or a theorem. Which one of those 3 specifically says that they're supplementary? Yeah, the theorem. So this would be the linear pair theorem. And then, see the word supplementary? We look at the definition. Supplementary definition does say it equals 180, so this would be our definition of supplementary. So in fact, this was a series of unpacking. I had to unpack what linear pair equaled, which was it could equal supplementary. Supplementary means it's 180. Did anyone find a shortcut for this one? Yeah.
I don't have the answer for a shortcut. But
Okay.
Why wouldn't that be, could you say that a transitive property for that one? Since you're adding that both to 180?
For this one, no. You have to describe what supplementary means. I never said it equals 180. You cannot just assume it equals 180. You have to tell me why it equals 180. It equals 180 because of the definition of supplementary. The only time you can use transitive is if it said measure of angle 1 plus measure of angle 2 equals 180, measure of angle something plus something else equals 180, and you basically, nothing got replaced here. We replaced supplementary with 180, which is not the transitive property, it's the definition of supplementary. Got to be careful about that. I'm going from a word to a number that's either a definition, a postulate, or a theorem. The only time we're using transitive properties if we're going from a number to that same number or a letter to that same letter. If you're replacing a word with a number, you better be using a definition or a supplement. The definition. Is that better?
Yeah.
Okay. Okay, other questions? Questions going once? Going twice? So then, let us look at a couple more proofs today. Did I skip some? Oh no, these are all homework questions, right? Oh, we're going to do an interesting one. A circle proof. And we're going to do a proof on a circle. It's actually relatively easy. So real quick, some information about a circle. The definition of a circle is the set of all points that are equidistant from a given point called the center of a circle. So you have a center of a circle, and basically you take a string and you spin it around. Now, this distance right here is a very specific name. It's called your radius, if you remember that at all. This is called a radius. A radius is the quickest way from the center to the edge of the circle. Now, the other word we're going to look at is diameter. Diameter is the distance all the way across the circle as long as it goes through the center. It's basically 2 radii that are straight opposites of each other. So those are the terminologies we need to know. We need to know what a circle is, what a radius is, and what a diameter is. Are we clear on those 3 things? Radius is half, diameter is all the way through. So we are given BC and DE are diameters of circle A. We need to prove that BC is congruent to DE. It's actually relatively easy to do. So let's go ahead and do the point we're all going to get. You better get this on the test. And that is BC, and DE are diameters. And I'm going to stop there. I'm just going to put they are diameters. That's good enough for me. And that is our given. Okay, we're trying to show that BC and DE are the same. So we need to show that BC and DE are the same. Yeah.
So is the middle point of the circle the name of the circle?
The middle of the circle is the name of the circle. Yes, A. So it looks like we can just say they're equal, doesn't it, almost? Because they're diameters.
Yeah.
But we never ever said diameters are equal. This one just says there's a given point called the center of the circle, and that distance, which is called our radius, is equal. So all we have is a definition of a circle saying that the distance from the center to the edge of the circle are all equal. So think about what that means. By definition of the circle, all the distances from the center to the outside are equal to each other. So we can go ahead and list all of those things being equal. So we could do something like AB is equal to, make sure I don't miss any of them, I'll just keep using A. AC is equal to AD is equal to A, what's our last letter? E. And that's basically a definition of a circle. Definition of the circle says from the center to the outside are all the same. That's the definition. Now we have to somehow get all the way built up to that BC is equal to ED. Well, say that again?
AB plus AB.
Yeah, we can go AB plus AD equals that whole length, right? Yeah, go.
Would we put tick marks on the line?
We could absolutely put tick marks on the line. I love it. We could put tick marks on all of these, which reinforces the idea they're equal to each other, right? So it feels like this is so easy I can just say they're equal to, but we need proof to back it up. So we proved that all of these segments are equal to each other. Now we're going to use that segment addition postulate to build up the big lines. So we could do something like, well, we got AB plus AB plus AC probably for that one. AB plus AC equals that long line BC. Do we have room for putting it in two? Yes, we do. For the other one, we're going to put AD and AE. Yes?
I was
You sure?
I was gonna go out from there.
I'll write this down real quick, and then we'll go over it. So I have AD plus AE equals the other segment, which is DE.
I see it over there.
You okay?
I was thinking like you had to prove AB equals BC.
Oh, okay. No. That'd be easy. We're done, right? No, we can't make it that easy. Okay. So now what I'd like to do, I would like to look at these two segments here. What I'm looking at right now is I would really like to write, let's picture DE. If DE basically said, oh, you know what, AB plus AC equals DE, we'd be done. Can we make it look like that? Is there anything that says that I can replace AB with AD? Yeah. We can use substitution. Perfect. I would use substitution there because we're substituting it into part of equation. So we're going to go ahead and our step 4 is going to be, well, instead of AD, let's put AB there. Instead of AE, who can figure out what I'm going to put in place of AE? I'm going to put AC. Thank you. Equals DE. Does anyone follow on why I did that? We just add them? Not quite add. I think you're on the right track. You're just saying something a little bit off. I think you're on the right track, but just to be clear, why did I write it like that? what would our next step be? Yeah,
We substituted
we're going to substitute again. What are we going to substitute?
A, B, and AC.
A, B, we're not going to go back. We already have A, B, and AC. There's something I want to substitute there, though. And I want you to focus on this. Say that again?
BC.
We're going to replace it with BC. So right now, I turned this side to look like AB plus AC by saying, okay, everything's equal to each other. Because this then allows me to replace all of this with just BC. Oh, I should probably put that we use, I haven't writing any of my reasons down. 3, we should probably put our segment addition postulate. And then we said we use substitution. Bless you. And we got to our step 5. I'd be okay with transitive or substitution there. I'm going to go ahead and I'm going to use substitution again. Oh, I already used substitution. I'm sorry. But I haven't written down this step yet. We now have BC equals DE through that substitution. You need to be able to see those steps. That's where that practice comes in. This happens a lot, where we replace letters to make it look like the other thing. So my goal is to either make DE look like BC or have BC look like DE. I chose make DE look like BC by replacing these letters to match what BC equaled. Then I can substitute BC in. So now we have BC equals DE. What's my last step? Definition of congruent. So we know our last step is definition of congruent by going BC is congruent to DE. I do see a lot of passive people in the class right now. Remember, you have to be active in this stuff. Don't just wait for someone. Make mistakes. Raise your hand and say something wrong. That's how you learn. You learn by going out on a limb, being wrong, and learning it. You don't learn anything from waiting for someone to answer and then copy down what they said. That's just straight up copying. I have a book with all these things in it. If you want to just copy them down, you can copy the rest of the year down. You got to participate in this stuff. All right. That was a circle theorem. We're not going to do a ton of circle stuff. It's on there just so you can kind of see it. More of just in our lessons so we can see it. I'm going to talk about how do you prove a theorem. So we have a theorem. We have a theorem that says if two angles are each complementary to congruent angles or the same angle, then they are congruent to each other. Let's find that theorem in our sheet. Yes? It is the congruent complement. If you look at congruent complement, it says the same thing. Now, here's the big thing about proving theorems. You cannot use the theorem to prove itself. It's kind of like if I give a definition for a word, I can't use that word to define it. I can't say the definition of a table is a table. You have to use other words. So whenever you're proving a theorem, you have to use other postulates and statements or theorems to prove it. You cannot use the original theorem to prove a theorem. That's redundant. So basically, when you see a theorem written up here and you have to prove it, you basically in your mind have to cross it out of your packet. Don't actually cross it out because it exists and you have to erase it, but in your mind, it's crossed out. We cannot use that. So keep that in mind. We cannot use this theorem because we're trying to prove that theorem. Let's go ahead and prove it then. So it says angle A is complementary to angles. I'm going to stop right there. We know we have to write down given. What's my next step as soon as I read that? Yes? Define complementary. I already know my next step is definition of complementary. We need to start having that knee-jerk reaction. That when we see a fancy word, it's either a definition. Most of the time, it's a definition. For linear apparent vertical angles, it means look for a theorem or a postulate. But for complementary, it means definition. So we know our first one's given. Our second step is to say they equal 90 degrees. Thank you. I want to make sure we have room for both of them. We do. So I'm going to go ahead and I'm going to put step 2 is measure of angle A plus measure of angle C equals 90 degrees. And we have a measure of angle B plus measure of angle D equals the old 90 degrees. I should write given and definition of complementary angles. Did I even look what I needed to prove yet? No, I call these knee-jerk reactions. I'm already on step 3, and I barely have to know how to do a proof. I just have to know, if I say a fancy word, you define what it means. So that's what we did. Now let's look at what we got going on. Now we also have angle C is equal to angle D. That should probably have a congruent symbol on it. Let me double check to make sure that's what I wanted on there. So we're all doing the same thing. No, we're going to go ahead and put measures on those. It'll speed this up a little bit. We'll put measures before it, so then we're okay there. Okay, then we have to prove that angle A is congruent to angle B. So we have A goes to C, B goes to D, but C and D are equal to each other. So we have a link between all of them. Yeah?
I don't know if it's right, but it would be like CD plus AD equals
CD. Say that again?
CD plus like AD maybe.
Yeah, that's what we're going to try to do. We're going to try to get these things equal to each other in a statement. But first, let's put the next given down, because we haven't done the given yet. So our other given is measure of angle C equals measure of angle D. Our step 3 is another given. Now, this is the story oldest time for proofs. I need to get A and B on opposite sides of an equation. So I need to somehow combine these two statements together to create one long statement that has A on one side and B on the other side. Does anyone know the statement that I would like to write right here? I want us all to think of something. Don't wait for someone to give an answer. Think about what I'm going to write in this next thing that has to be a statement that has angle A on one side and B on the other side. Looks like we're weighted on the right, no one on the left-hand side knows it. This is something you're going to need to know how to do for proofs. This is what we've practiced for. This step right here, we've done it a million times already. Not really a million. All right, those of you without your hands up, you better pay attention to this step. You should know this by now. We have a test next Thursday. Alejandro, what do you think I'm going to write in the next step? We shouldn't write definition of supplementary because we don't have 180. I never said anything about supplementary, though. I'm looking for an equation. Joseph? Angle addition postulate. Probably not an angle addition postulate because we're trying to add. I like the feedback, though. That only works if I have a small angle plus a big angle and they're next to each other. So if I would have C and A next to each other, that's when I use the angle addition postulate. Matt?
Definition of a right angle?
Definition of a right angle. Probably not definition of a right angle. We only use that if we want to prove it's a right angle. We already know it's 90 degrees. I'm looking for an equation. Savar? Substitution. What would I write?
Angle A plus angle C equals angle B plus C.
Yeah. If you ever see this, do you see this statement right here? This statement automatically means you need to look at how all of these are linked up. That goes to 90, 90 goes to 90, and 90 goes back to this. This will, 99.9% of the time, anytime you see this, you're going to write this as one long statement without the 90 degrees. So I'm going to combine these two statements into one long statement that goes like measure of angle A plus measure of angle C equals measure of angle B plus measure of angle D. You need to understand that happens so many times in proofs. If you ever see two things equaling a number and two more things equaling that same number, it typically means you're going to put those two things together. Do we now have A and B on opposite sides of the equal sign? Yes. My whole goal is to get rid of measure of angle C and measure of angle D. The only way you can do that is if they're equal to each other. Are they equal to each other? Yes.
No, but can't we like substitute
That's perfect. So we know they're equal to each other. Now we have to tell the reader that they're equal to each other. So we're going to take maybe this D and plug it in for that C. That will give us our step 5, which would be measure of angle A plus measure of angle D equals measure of angle B plus measure of angle D. Ooh, I forgot to write down stuff. Step 4 should have been transitive. I hope you put that down and you're not just waiting for me to write it. Step 5 will actually be substitution because I'm substituting something into the equation. Yeah?
Why is number 4 not substitution?
You could use substitution. Transitive is better. Transitive is a little better because it's this links to 90, 90 links to 90, 90 links back to this one. It's a whole bunch of links. Remember, if you're ever stuck between transitive or substitution, pick substitution because it almost always works in place of transitive. So if you're not sure, it's just transitive is a little nicer. The way I picture it is, so say you have a screw. Say you have a screw and you have a hammer and a screwdriver. You could take a hammer and nail down a screw. Is it the best way to put a screw in? No. Will it work? Yes. It'd be better if you took the transitive as the screwdriver in this case, where the hammer will work, but the screwdriver would be better. And on a test, if you put substitution where I want a transitive, all I do right now is I put a little arrow and I put transitive would be a better here. Because we're going to start getting into proofs where you cannot use substitution, and not in this unit, so don't worry about it right now. Now we're just getting comfortable with the terminology. So don't just go on and put substitution every single time. Start thinking about when transitive is a little bit better. Yeah? Say that one more time. I'm sorry. Yes, I would say, I would do something like this. Prove that this theorem's true. And then I would give you this stuff. Okay. So now I need A and B alone. How do I do that? How do I get rid of D and D from both sides? Subtraction property of equality, or PO. So our step 6 will be, we're basically subtracting angle D from both sides. We have measure of angle A equals measure of angle B because we subtracted basically D from both sides. That is our subtraction property of equality.
Then you just divide that out.
Not divide the m's. How do I go from an equal sign to a congruent symbol? Definition of congruence. So you need one more step that says angle A is congruent to angle B. Definition of congruence. I went to the wrong slide. I don't have the room to put it in there, but your step 7 should say angle A is congruent to angle B by definition of congruence. Look at step 2 and 4. 2 and 4 happens a lot in proof writing. This is almost a knee-jerk reaction. If you ever see 2, it's going to go to 4, where you're going to take those 2 statements and write it on each. Is it going to work 100% of the time? No, but 99% of the time, if you see this, rewrite it as one long equation. That's a nice knee-jerk thing to do if you're not sure what to do next. So if you see something like 2, write it like number 4 where you put them on either side. All right, we have one more to do and then we're done. Given AC is perpendicular to BC and we have angle 3 is complementary to angle 1. Here's the nice thing about this. We actually have 2 things we need to explain. The first thing we need to explain is, what does this mean? AC is perpendicular to BC. That is given. This is a good time to look up. That symbol stands for perpendicular, if you don't remember. Now is a great time to find something in the packet that talks about perpendicular. Remember, do not guess at the definition. You have to use the exact wordage it says in the definition. Don't go perpendicular 90 degrees, because if you read the definition, it says nothing about 90 degrees. What is the key word that they use in the definition? Ty? Ty's going back and forth between wanting to give an answer or not. Do you have it? It should just say perpendicular. Like definition of perpendicular. Not perpendicular bisector, just definition of perpendicular. Yeah. Okay, form a right. Does it say at 90-degree angle? Oh, cool. Then which one are we going to use then? What seems more pertinent here, that it's a right angle or it equals 90 degrees? You think right angle?
Yes. Yes.
What does complementary mean? It adds to 90 degrees. Does it say right angle in complementary? No. So what seems more important? Probably the 90 degrees. And in fact, most of the time the words are the harder thing to use. The numbers are the easier. So we're going to use the definition to then say a particular angle equals 90 degrees. What angle am I talking about? I have mine cut off a little bit. What angle equals 90 degrees? We need 3 letters. I got AC. We need another one.
BC.
We name an angle using 3 letters. Don't just throw out pairs of things at me. ACB is correct. We have to know how to label an angle. It is ACB, and that equals 90 degrees. And that's definition of perpendicular.
Yeah, how does that not equal 180 for the ACB? Wouldn't you have to have another point where it would be that intersection between A and B for it to be a right angle, so then be AC and then that?
I never said it's a perpendicular bisector. I said it's a perpendicular lines. Perpendicular lines. Perpendicular bisector cuts things in half. Perpendicular lines look like this. They form a 90-degree angle. Those lines are perpendicular. Nothing about bisector, nothing, because bisector lets you cut things in half.
Yeah.
This is straight up, if you see the word perpendicular, it's 90 degrees. So if I say it's perpendicular, that means I put a 90-degree angle right there, by definition of perpendicular lines. That's why you got to be comfortable with those terms. Yes?
Why isn't that a definition of a right angle?
Because they didn't say right angle, they said perpendicular. You can't pick the words, they used the words. They said a line is perpendicular to this line. You have to look for the word perpendicular. You can't look for things that are close to perpendicular. You have to find the thing that says perpendicular lines. So this says perpendicular lines. I find perpendicular lines in my thing. Just don't overthink it. It tells you the words to use. Like if I say complementary, you shouldn't be looking for right angle. You should be looking for the word complementary. Is that a little clearer? So perpendicular lines, definition of perpendicular lines. Next statement, angle 3 is complementary to angle 1. That is also given. What's automatically my next step?
Define complementary.
Define complementary. And what does complementary mean? A 90 degrees. So these add up to 90 degrees. So we're going to have step 4 is measure of angle 3 plus measure of angle 1 equals 90 degrees. Definition of complementary. Okay, so we have ACB equals 90 degrees. We have 1 and 3 are equal to 90 degrees. Can we split apart ACB so we can start using numbers there? Like 1s and 2s and 3s? Is there a way to rewrite ACB using 1s, 2s, or 3s? I see people shaking their head. How?
Substitution.
Hang on. Don't just start things out. Think about it. What allows me to say an angle plus another angle equals the big angle? Yeah.
The segment addition postulate.
Not segment, but we're doing angles now.
Oh, angle.
Angle addition postulate. So my angle addition postulate is going to allow me to say measure of angle 1 plus measure of angle 2 equals the measure of angle ACB. That is our angle addition postulate. We have to be able to see that. Do you see how ACB is comprised of angle 1 plus angle 2? That's why we can't just shout things out. We have to really think about what's happening here. We have angle 1 plus angle 2 equals that. Okay, what does ACB equal? 90 degrees. Let's put that in there because we already have something equaling 90 degrees, right? Remember, my whole goal in a lot of these problems is to create this statement where I have two things equaling the same thing. So what I'm trying to do is I already have that 3 and 1 equal 90. I want 1 and 2 equaling 90. So that's what we have here. Our step 6 would be measure of angle 1 plus measure of angle 2 equals 90 degrees. That would be, transitive would be the best one. I'd be okay with substitution. Think about transitive here. Because we have this equals ACB. ACB equals 90. That seems like a train of events. That is a syllogism. So I can now say angle 1 plus angle 2 equals 90 by transitive. And let's see if anyone paid attention to me on that last proof. What is my next step? It's the exact same as the one we just did. I said every time you see this, you do this. This is where we need to participate. I just told you how to do this. It doesn't mean you know it, but I just told you what to do, so you probably should have put a note next to it. And if you didn't, maybe now's the time to put it in there. What do I do next? Think you got it, Joseph?
Would it be you substitute 3 with 1 because it goes, gets married?
You're close. We can't substitute 3 in for 1 because we don't have those equal to each other.
Oh, wait.
You're close. Substitution is correct. What would I substitute instead? Savant? Oh, you got the last one, I think. Did you do the last one? Okay, then let's do this one. What was that?
3 would substitute for 2.
3 substitute for, we don't know those two things are equal to each other. All we know is this equals 90 and this equals 90. So these are our key things. And if you didn't write a note last time, you better write a note this time because a lot of you still don't. I said this is one of the most important things from today. Joseph, what do you think I write? You write them equal to each other. You write measure of angle 3 plus measure of angle 1 equals measure of angle 1 plus measure of angle 2. This makes me a little leery on how much you're actually doing the homework or copying stuff. Because this is something you need to start realizing happening. If I told you this on the last problem that's going to show up again, you might want to put a note down that when you see this, put stars by this. This happens. When this happens, this happens. Now, we can cross out measure of angle 1, right? So that was substitution. We can cross out angle 1 from both sides because we can use what property? Not substitution. Subtraction property of equality. We'll use subtraction property of equality to go measure of angle 3 equals measure of angle 2. And that is our subtraction property of equality. Surprisingly enough, this is just barely a medium problem. The one before it is probably an easy problem. And they're easy and medium only because this one doesn't straight up give you these two equations. But this one does give you the two equations. When you see this, you have to know to put them equal to each other. You just have to. I can't do it every time for you. You just have to know that happens, which means you need to write it in your notes, and you need to pay attention to when it happens in proofs. Even if it's a scaffold proof where I show you every step that's happening, you should circle every time this happens and what happened. Because this is a huge thing that happens in proofs. Just like definitions, unpacking things. You make these small little steps and proofs become easy. Like if you knew before this to look out for this, these two proofs would have been probably a little easier. You just weren't prepped to look for these. That's why I picked these two problems so you start recognizing this happens. Questions? Okay. the rest of your, how much time do we have left?